So good morning, everyone. Good afternoon. My name is Kevin Brown. I'm the SVP of Innovation and CTO for the IT division of Schneider Electric, and I wanted to spend a little bit of time today talking about edge computing, which is a term, and I'm going to ask everybody in the audience, how many people actually understand what edge computing is? I want a show of hands. Give me a quick show of hands. Not surprising. We got about 50% of the people have some idea of what it is, and that's not unusual. We've been working hard within my group and within the Data Center Science Center on trying to understand what really is edge computing and what does that mean. And what I wanted to present today is a little bit of that research that we have that we publish in these white papers. By the way, we fund every year a group that's dedicated to doing nothing but research into these types of activities, these types of trends in the industry. And for the most part, we make all of that available publicly via our trade-off tools and our white papers. So this is internal research that we do. We use it for our own internal purposes, but we also put it out into the broader public domain because we think it's something that we can help contribute to the industry. So the title of this presentation says why cloud computing is requiring us to rethink resiliency at the edge. Okay, so that's a lot of fancy words, but in effect, what we're talking about is that the world is changing in terms of how people are approaching compute, how IT people are deploying their compute, and all of that's having an impact on how do we want to build and design our data centers. And it's really trying to put some framework and some theories out there on what we think is going to evolve as time moves forward. And so some of that's being driven by, there's tons of slides like this, digital traffic is expanding 8%. I just saw a statistic recently that said in the last 2 years, we've generated 90% of all the content that's ever been generated in the world. So we know there's this explosion of content that's occurring. And then you see a lot of the growth is we talk about the Internet of Things, which, as we like to say, really depends on the things more than the internet in many ways in terms of what those things are trying to do. And one of the things that's interesting is, and I've seen these data points presented in many different areas. One of the ones that's interesting is a 747. I have no idea whether this is true, but we found this as a data point, right? But they claim 40 terabytes is transmitted for every flight that's happening on a 747. So that's an amazing amount of data if you start thinking about it. And that trend is not going to stop. We have more things that are coming out. They're going to become more intelligent. There's going to be more data. And ultimately, we have to start figuring out, as an industry, how do we handle this in as robust a way as possible? And what's interesting, too, is while that is occurring, at the same time, every enterprise that we ever talk to is doing the same thing, in effect, is they are looking for a way to go into cloud computing. Whether they're moving to Office 365, Gmail, they're getting off of traditional enterprise applications wherever they can, and they're trying to move them into some kind of a public cloud architecture. But not everything is moving. They can't move all of their applications. There's some applications where it may not make sense economically to re-architect them for a cloud platform. There's some cases where they just may choose because they view it as mission critical or more appropriate that they would keep it in-house. So these trends aren't changing, and this is really a different dynamic. If you went back 5-10 years ago, there was theories that were being put forward in conferences and shows that talked about, in the future, we will only have 5 data centers, and they'll most likely only be in Silicon Valley in California. Right? Because everything's going to move into the public cloud. There was theories that were out there that people were presenting saying, why would you ever have your own data center? And certainly we see that trend happening, but what we're learning is not everything can go. So things are going to be left behind. And really, why is that occurring? Why is stuff being left behind? I would argue that the centralized cloud theory that I just proposed of 3 or 4 big data centers that would be all that's in the world, most of the time, people were thinking of specific types of applications where that type of architecture is quite appropriate. And 3 that we are highlighting here is you think about email. Okay, if I don't get my email instantaneously, unlike my children, it's not the end of the world. Okay, so it's okay if I have a slight delay. It can take time for the packets to go to a big data center somewhere and come back. That extra 200 milliseconds doesn't make a difference to me. Payroll applications is another good example where we run payroll although it's all very important to all of us, right? I understand. But the reality is if it takes a little bit of extra time, it's not a problem for us. So it's an appropriate application to go out there. And certainly social media, okay? Despite how fast people might need the latest video of a cat chasing a dog or any video that you might want to see, it's okay if it takes a little bit of time to move from one server to another. Okay, it's okay if I post it and then my friend can't get it for a few seconds. We don't really care. Okay, but that's not appropriate for all applications. Not all applications work that way. And here's a few examples that we bring up. Anybody who has children, I think, can relate to gaming. By the way, and I'm going to start to bring up a few analogies during this talk, but for years, my internet access at home was perfectly fine. Everything was, my wife and I came home, I would get access, I could go to email, I could do my web browsing, I could do everything I needed to do. And then my teenage son discovered CSGO, which I'm not even sure what that stands for, but it's one of these online video games, and suddenly I was rewiring my network inside my house because the latency of the wireless network was too poor in order for him to handle his gaming system. And by the way, I had to have my router replaced, and I had to call my internet service provider to make sure we were getting the bandwidth that I was paying for, and they ended up having to replace devices out on the pole outside of my house. All of this because my 13-year-old wanted to play CSGO. Okay? So this is a big change that's happening. This type of application cannot sustain a traditional internet. It can't sustain a traditional centralized cloud. Uber is another one. Self-driving cars. I don't know about you, but 20 milliseconds versus 100 millisecond delay might make a difference if I'm in a car that's driving itself. I don't think I'm going to get in a car that's going to have to rely on compute that's going to happen in an Amazon cloud, a Google cloud, a Microsoft cloud, and then wait for the computation to happen and come back. Even if it takes a little bit of extra time, it could be the difference between having an accident and not having an accident. Those types of decisions are going to mean there's going to have to be compute locally to make that type of decision. And certainly when we see what's happening in healthcare between privacy regulations, the speed with which they're trying to do imaging and MRIs and be able to quickly get results back, it's likely that we'll see things in healthcare also where you'll require local computing. So this centralized cloud theory didn't really comprehend these types of applications that have developed over the last 5 to 10 years. And because of that, you really can boil down what are the things that are going to drive. We're getting to what is going to be edge computing, which is somewhere close to where the application's happening, and it will be application specific, depending on the latency that it requires, depending on the bandwidth that it requires, and depending on the government regulations, which might drive us to have more local data centers. These are 3 big issues that are really application dependent, which is another big change for our industry. We now have to start thinking about what is the specific application requirements and then build the infrastructure to fit that requirement. And I'm talking about the IT infrastructure, physical infrastructure, everything is starting to become much more application dependent. So what does that mean? Maybe a way to think about this is that edge computing is a high performance bridge to the centralized cloud. So you're going to have something in between the big data center and the local application. That's fundamentally, conceptually, what we believe is going to be edge computing. So that's kind of an introduction into what we think it is. And there's no question that we see this happening in real time. This is a theory we're putting forward, but it's already happening. Microsoft is already announcing that they're going to have more regional data centers. Most of the internet giants, there's stories about where they're starting to deploy, at least, say, in Europe. They're not going to drive everything out of the US. And one of the things that's driving this, by the way, like Netflix, has anybody heard of Netflix here? Okay, it's a new thing, right? But with Netflix, one of the things that's interesting is they actually distribute their content out locally. So they started off streaming all of their data from a centralized data center. What they discovered was it was more economic to start putting physical IT gear out into co-location providers and then store data locally. And it was purely an economic decision because now their bandwidth costs went down, and that offset the cost of actually putting the equipment locally. So this content distribution, every time you guys watch a video, and I'm assuming you guys watch a video from time to time, every time you watch a video, what you're driving is edge computing because it's going to start forcing the content providers to put things more locally. So, it's what's proving out is that we're not going to have one or a few big data centers. We're going to have multiple data centers throughout, depending on the application that you're trying to run. So this puts forward our theory that in the future, and what we're seeing happening right now is there's going to be 3 types of data centers that exist in the world. One, what we call the centralized cloud data center. That might be running social media, some of our email systems, applications like that. It's very likely that those will be stored in some big centralized cloud data center. Conceptually, we think there'll also be these regional data centers that get deployed, for instance, like our content distribution. They'll be somewhere in the general region that you're having. It's not, I don't think it's wrong to think of this as like typical colo or even enterprise data centers where they're sizable data centers, but they're located somewhere in the general region that we're looking for. And then the one that we think is emerging, which really creates an interesting description that we're going to get into in more detail, is what we're calling localized or micro data centers, is these very small implementations that are going to be left on site, right? Where this have to be very close to the load, very close to the application. And those we think are really an emerging area that's starting to develop inside of the marketplace. Now the dynamic that you're getting into when you look at this though, is we think, right? We think when we go into something like an Office 365 environment or a Gmail environment, one of those types of environments, the belief was initially that, that's going to make our lives simpler. Because when I make my life simpler, right, that's going to be better. Well, if you go back to the theory of the three types of data centers, actually what's happening is the data center environment now is becoming more complex. Because now I have to worry about all three of these data centers. Is my Amazon, Google, Microsoft data center running? I've got my own regional data centers that I might be worried about, or my own stuff in a colo. Plus I've got these small data centers. I've got a much more complex system now than I may have had in the past. So what does that mean? Okay, so in centralized and regional data centers, our industry has done a good job. Okay, when I say our industry, again, we're the power and cooling guys, right? All the glamorous stuff that we do, okay? We have a great set of best practices that have developed over the last 20 years. And you go into some of these co-location providers, I can't get into any data center without giving them my license, an agreement that if I take a picture, they get my firstborn son, which sometimes it makes me want to take a picture. However, there's a highly structured security mechanism in place. They have biometrics security at the doors of some of these racks if a customer wants it. There's man traps so you can't come in. There's one data center provider that is well known for hiring ex-military people as their security guys. And when you walk around, they follow you. So you have an armed guy following you around inside of this data center in order to ensure that you don't do something wrong. Locked organized racks, we have redundancy of critical systems, and then generally they have a NOC, a network operations center, that's monitoring everything that's going on inside that data center at all times. So we've got a pretty good system set up. Despite the outages that you might hear about in the news, our industry has done a pretty good job at designing very robust centralized data centers. And then we generally take those and connect it to something that looks like that. Okay? I know we don't have anything like this in our building. But let me tell you, there's no shortage of server rooms, branch offices, wiring closets, whatever you want to call them, that look like that. They're unsecured. They have no redundancy, poor cable management, no monitoring. There's no dedicated cooling many times. You go into some of these server rooms or little wiring closets, they could be the hottest room that you can find, even hotter than this room that we're in right now. So this also, I believe, is introducing a very big cybersecurity threat because the first step of cybersecurity is making sure you have physical security. If somebody can get physical access to your network, then that's the easiest way in. So this is going to have to change, okay? And it has been changing slowly, but we think this is going to have to accelerate rapidly inside of our industry if we're going to do that. So the fundamental assertion that we're making is that as companies start moving to this hybrid cloud environment, as they start moving apps to the cloud, the edge sites and their connections become more mission critical. Hopefully that makes sense, that the thing that I'm connecting to is most critical. So we started with this theory, right? And you can kind of see the logic. The logic makes sense, but we started trying to put some numbers around it. So anyway, the trends we are facing here also, we talk about the millennials, and I started talking about my son, right, with the gaming that's happening. Let me tell you another story about the expectations we think are going to change in terms of IT. So the analogy I like to use here is if you were somebody who lived in the United States, say in 1880, 1890, right at the beginning of electrification happening inside of our country. In any country in the world, 1 week I was living, I had no electricity. The next week they turn on the electricity and I think it's great. 2 weeks later, the power goes out. Is that a big deal for me? Okay? And the answer is no, right? Because I already knew how to live without having electricity. I just went back over here and, okay, I'll do what I used to do before. Then when the power comes back on, then that'll be a nice little luxury to have. So my argument is, our generation, my generation, so sorry to insult everybody in the room who might be of a younger generation, my generation is a lot like that. If I go home at night and my network's not working, to me it's kind of a benefit, right? You know, all of a sudden I'm disconnected, I don't have to deal with anybody. But for my kids, if they come home and the network's not working, it is a major ordeal. Trust me. Okay. And you know, I was having a moment with my 16-year-old son one time, right? And we were trying to discipline him, and I tried to do all the standard things my parents did when I was a kid. They're like, you know, you're gonna have to stay in your room. I say, I don't care. Right? You know, well, I'm gonna ground you. He goes, what does that mean? You know, you better be careful, I'll be really angry. He goes, well, you're angry with me all the time. What does that matter? And he said, okay, give me your phone. And you would have thought the world ended. The thought that I would take his phone away and disconnect him from his friends, his social media contacts, that had an impact. That got the behavior to change, and I recommend it for any parent who's doing it. But I guess I hope that kind of gives you illustrate what we think is happening here is the expectations of our IT systems. It's turning into being more like the electrical system. We expect it to be there. It must be there. It was not like that 5, 10 years ago. If things just turn off, it wasn't a big problem. Second thing, which is in the middle of this slide, I love this one. This is one of my favorite pictures of all time, is you see you got this little tiny, I think it's like a chihuahua or something, but he's chasing this big rhinoceros, okay? And what the point of this one is, size doesn't matter. Because of what's happening with the hybrid computing environment, we have a natural instinct inside of our industry, particularly people who've been doing it for as long as I have, where you tend to look at like small little one-rack installations and you say, they're not that important. We don't really care about those. They'll just be fine, okay? And this new environment we're going into is that mentality is going to have to change. So it's a different culture that we have to start thinking about. Is it's no longer going to be about, I got to worry about my big 1 or 2 megawatt data center, 10 megawatt, 20 megawatt, whatever size that you're building, and say, geez, I got to watch that. All my eggs are in one basket. I better watch them really closely. And if I have a small little basket over here, it'll be okay. We think that's going to change. You're going to have to start worrying about those small little baskets that you have over on this side. And that this environment, again, reiterating what I said before, this is becoming a much more complex data center environment than what we've had in the past. Okay, so now what do I do about this? So I know I got this complex environment. How do I start thinking about it? So we started modeling this out, and we leveraged the Uptime Institute's tiers system for this. So how many people have heard of the Uptime Institute and tiers in the room? Okay, so you know, about half again. That's pretty good. But this is the accepted criteria that we use for measuring reliability of data centers, okay? And the Uptime Institute has pretty much established themselves as a standard in the industry for how I know if a data center was built with the right level of reliability. And there's 4 levels of tiers. There's 1, 2, 3, and 4. For the most part, tier 3 plus is kind of considered the sweet spot for a well-built regional centralized data center, okay? And so generally the cloud data centers we see at tier 3 plus, regional data centers at tier 3, and these localized micro data centers, again, given the pictures I showed you before, that would be considered tier 1, okay? Which is basically, you know, it just exists. So we look at that in this classification, there's an estimate provided. We didn't make these numbers up. This came from Uptime in terms of, for each of these tiers, what's the level of availability we get? And as an industry, we talk in terms of percentage of availability. And a tier 1 data center is 99.67% availability. A tier 3 data center is 99.98% availability. So it's 0.98% versus 0.67%. The human brain does not understand if that's a big difference or not, and in fact, we tend to think it's not a very big difference, right? If it's less than 1%, we stop thinking about it. But the reality is that's why we need to rethink this. And what we need to do as an industry is start thinking in terms of how many hours of downtime does that translate into? So this is just a math exercise. And if you do the math, what it translates into is a tier 1 data center has 28.8, about 29 hours of downtime a year, versus a tier 3, which has about 1.5 hours a year, okay? So that small percentage change that we're talking about, that's what it translates into in terms of hours of downtime. So now if you take the previous theory that, hey, we got to start thinking about uptime in terms of like an electrical utility, and we're going to start treating our IT systems that way, you know, the difference between 29 hours and 1.5 hours is a big difference. So this is one thing that we think the industry needs to start rethinking in terms of how do we measure this. We also think there's a cultural change that needs to occur because for the most part, I think it's fair to say that in our current paradigm in the data center industry, we tend to think about failure as a disruption to the IT equipment inside of the data center. There's different things that might happen. So suppose there's a power outage, we keep the IT equipment going, we consider that an event that occurs, right? But if the power is disrupted at the IT equipment, that's considered a failure. This is not the right paradigm to be thinking about. What the paradigm should be is more on the right-hand side, is did the user experience an interruption in their experience is really what's critical. Because if my power, let's go back to the electrical utility example, if the utility has a problem in the high voltage, right, part of the utility, but my power never goes out because they designed a system that's robust enough, so if their transformer went down, I still get my power. Do I care? I don't. Does the utility care? They do. So in our world today, we would define that the utility's concern was a failure, but we're not really considering whether or not the user's experience was interrupted. So it's a little bit of a subtle but significant change. So you got to start focusing. When you go to the right-hand side, you have to start focusing on what's happening at the small sites. You can't ignore those. You have to start looking at how's your overall system performing, not just how is my individual data center performing. So hopefully that makes some sense. So now if you buy into that, now we can start doing some math and say what happens. So if the focus of availability is only on the centralized tier 3 data center, if I'm in my old paradigm and only thinking that way, I go and I would expect and plan for 1.6 hours of downtime per year, theoretically, if I do a tier 3 data center. That's what I would expect to have happen. The problem is when you move over to the right and you say, I got to worry about is the customer having the experience that we expect, what happens is you have to start multiplying that tier 1 data center's availability in conjunction with that tier 3 data center. The two have to be multiplied together now. And again, this is just math. So you have a design now that you thought was 1.6 hours of downtime per year, but for people who are dependent on that localized tier 1 data center, they're going to experience about 31 hours of downtime per year. That's a big difference. And what starts happening as you start going through this math is the little sites are what dominate your availability equation. It's not about the big data center anymore. It's going to be about the small little sites. And if we want to get our availability up to utility grade. And then what about the number of people that are on site? I mean, it's kind of a logical question to ask as we started researching this. We said, you know, if I have a site that has 10 people at it versus a site that has 1,000, which one's more important? The 10 or the 1,000? It's pretty simple. The 1,000. I would worry more about that. Why is that? Because I have more people there. So it's intuitively obvious, but yet today in our industry, we have no way to talk about this. So we have no standards, no systems to measure these things. So we just did some math to see what it would look like. And you can see here is if I have, we did a model where I have 10 sites with 100 people at every site, and I've got one big tier 3 data center that they're all dependent on. And I'll let you look through the math, but now if I start thinking of man hours of downtime per year, as opposed to just what's happening to the data center. Because at the end of the day, we really care about people, I hope. Okay, maybe not always, but we hope. You end up with 31,000, excuse me, roughly 30,400 man hours of downtime per year. Now, so I've gone from thinking I had 1.6 hours of downtime per year. If I have 1,000 people that I'm concerned about, you're really talking about almost 31,000 hours of man hours lost, at least in terms of downtime. So you really start seeing as you look at this is that the availability edge dominates the equation. So as we look at that, we said that was pretty compelling, but then we started thinking about, well, you know, depending on what people do and what their job is, some things might be more critical than others. So in our building here, we have a call center. If that call center goes down, is that problematic for our customers? Of course it is. If my internet connection gets disconnected, is that problematic for our customers? It's okay to say no. At least in the short run, we hope it doesn't impact our customers. And in fact, my team would probably tell you their productivity goes up every time I'm disconnected. They like it when I'm on airplanes. But the problem now is that we have airplanes have internet access, so that's working against them. So the reality is, for somebody in my position, if I lose my internet connection for a couple of hours, hopefully, in the short run, it doesn't have an impact. I hope in the long run it might. Okay, but for our business and for our customers, it's really not critical. If our call center goes down, then we're having real trouble in real time. And so this also starts to need to come into the equation. So remember I talked about earlier, the application that we're running should drive, the needs of the application should drive what the design of the data center architecture should be, the system. This is also the same thing. Our call center application is much more business critical for us than the CTO having internet access. Okay? So we don't have any way of talking about this today in our industry. We have no metrics. We have no uptime tier standards to refer to this. But we started putting forward, you could start doing a scorecard like this, for instance, where I have these different sites. I can look at what my annual downtime would be based off the calculations I gave. And then maybe I start ranking, just qualitatively, what's the severity impact to my business if I had a failure that occurred? And if we start multiplying those together, and we like doing these types of scorecards and analysis, you can get a weighted for criticality score. And now I can see which ones are the ones that I should start working on first. And I've met with customers who are actually doing this intuitively. So all we're trying to do is put some more framework around it that we think the industry really needs to be looking at, because we've been too simplistic in how we've been approaching looking at availability for our IT network sites. So, the takeaway here is business critical edge sites are going to be the first ones that have to be designed to achieve high availability. So what are the ones that are business critical? Any company, the first ones they're going to look at is any business process which is directly impacting customers are going to be the ones they start looking at first, without question. Okay? The CTO, if he gets good access, that's, we'll deal with him later. Right? But if the customers are being impacted, we've got to make sure we're addressing that now. And we're seeing this starting to occur in the industry. I've met with companies that are actually having these discussions, but they don't know how to talk about it. They're not quite sure how to approach it. And this is why we're trying to put forward at least some ideas on maybe how, as an industry, we can start qualifying and quantifying what we're trying to do. So what would a robust architecture look like for these localized data centers? I think you're going to start seeing things like dual network connectivity coming in. We might have installations that are very small installations, 20 kilowatts, 50 kilowatts, 100 kilowatts, small is in the eye of the beholder, right? But where they're going to start putting in redundant power and cooling, which things that you see in a typical tier 3 data center will start finding its way into these very small installations. And most importantly is they're going to be highly secure environments. The physical security is the first step of cybersecurity. These things are going to have to start getting locked down. So what does that mean? What that means, obviously, if we see this trend happening, we're not just talking about this in theory, we're actually trying to help the industry. So it's not only the theory of putting in the white papers and putting this out, but we actually are doing investments in our R&D portfolio to try help with this. And many of these are starting to be realized this year in 2017, where we're rethinking how kind of pods inside of these regional data centers could be designed, or for smaller installations that somebody might have on site. And for the really small sites where it might only be 1 rack or 2 racks, this is where we're starting to think about what we call a micro data center, where it's a fully enclosed, tier 2, tier 3 type of approach that is being done inside of 1 rack. And this is why we're making these investments, because we think this is the direction and a problem that we need to help the industry solve. So that's the theory. That's what we're doing. Here are the resources that you can access that are all freely available. And hopefully, if you want to dig in, everything I just presented today is in our white paper number 256. Why cloud computing is requiring us to rethink resiliency at the edge. But we have lots of other resources around edge computing and what we're trying to do in this market. So I hope all of that made some sense. Again, it's a theory we put forward that we see evidence of it coming forward in real time. And this is one of the reasons that we see an opportunity for us to really help our customers solve their business problems, which is how are they going to raise the availability of their data center systems and their IT applications. Thank you very much.